Uh, so there's a Q on the Harry. Okay, let's start with power loss in XLP insulated power cable. In fact, it is applicable to all the power cables, means cable which are used in the industrial and distribution system. So, so when does power loss happen? So whenever the current flows in the cable, and whenever it is opposed by the resistance of the cable, then there will be the voltage drop, and at the same time the power loss happens in the cable. So it is also called as I square R loss or kilowatt loss. So uh, power loss are directly proportional to the current flowing through it, resistivity and length of the conductor. If current is more, the obviously loss will be more, and resistivity and length is also the factors for the power loss. So yeah, and area is inversely proportional to the power loss. So we generally know that high size, I mean high square cable often leads to low loss because of its power handling capacity. So yeah, this is one general formula for to calculate the power loss in cables. So I square R, we know that R equals to resistivity times the length by area of the cable, and power loss in one particular cable is given by number of cores, current square, resistivity, length, and area, and 1000 into per kilowatt. So we can see from the description what is N, I, rho L, and yeah, and resistivity of the conductor material is also given. General copper has low resistivity, and it has high current carrying capacity as compared to aluminum and silver. Its value is 1.68, 10 times 10 to the power minus 8 ohm meter. Similarly, for aluminum, it is 2.65, 10 power minus 8, and silver 1.59, 10 power minus 8. So let's see one example. It is one real example which I had carried out in the project. So yeah, total power is 86 kilowatt, and considering the copper conductor for the connection, resistivity of the conductor, we can see 1.6 at 10 to the power minus 8 ohm meter, and it was from installation point to the grid connection point, it was approximately to 93 meters, and we have used 4 core cable, 3 phase AC, RYB and neutral, and its current in normal condition was 48, 146 ampere, and derating factor, considering the depth of marine, ground temperature, soil resistivity, and ambient temperature, it came to be 0.97, and corrected current is 1.51. How it came? Normal current 1.46 divided by 0.97. So we selected the cable which has the uh, current carrying ability of 151, greater than 151 ampere, and we selected 70 square mm, 167 ampere, and our mode of installation is direct buried. And from the catalog, we knew that the voltage drop of cable is 3.35 millivolt per ampere per meter. So considering the three phase AC 415 volt AC, we see that 0.35 times per ampere means 146 ampere, and meter means 293, and if we divide by 1000 we get 3.6% in 415 volt AC, which is quite acceptable on relatively 5% consideration. And we it is power loss as we saw in the previous formula. We get power loss of 2.87 kilowatt, which is 3.34%. uh, in what we usually practice in industrial power distribution is that we try to maintain the power loss under 2% or maximum 2%. So it is considered as a good practice to have the loss under 2%, or at most 2%. So yeah, in this, what should be the length as well as the area of the conductor if 2% power loss is desired in the industrial distribution. So from that formula we substituted the length and power loss. We are committed to have the power loss only 2%, and 2% with optimal operation. And so with the calculation we can see that length of cable a route should be approximately 84 meters to have the power loss of 2% of the installed uh, power. So what would be the area of the conductor to have the 2% loss with 84 meters? So on putting the value we get area 245 mm square. If this is the one of the standard practice to have the 2%, and under being limited with the constraint of 2% power loss, we get the area of the conductor as 244 millimeters, 245 mm square. So when selecting cable we should opt for greater than, which is standard available in the market. If I think the most standard available in the market is 240 square, or if it is more than that, then it is good. But we try to select the market standard uh, cable size only. So yeah, this is one of the example, and we can know from this that we can calculate for the future reference. So yeah, thank you.